Our I can statements for this video are N10. I can convert a rational number to a decimal by using long division. And N11. I can explain that the decimal form of a rational number terminates or repeats. So here are our rules to turn a fraction into a decimal. First, you're going to put the fraction into the division bar. So the numerator is going to go underneath the division bar, and the denominator is going to go out front. The next thing you're going to do is place a decimal. It should come after the last digit and above the fraction bar in the same place, and then you'll add in some zeros. And remember, any zeros after the decimal point, you can add in as many of them as you might need. Then you're going to start the division like normal. And if you need a review, remember that you can watch that review long division video to help you get started with long division on whole numbers. Here's a way to remember which numbers go where in the division bar. So the top of our fraction is the front of the line. The bottom is the back of the line. This is the same with our numbers written in division form. The first number is the front of the line. The last number is the back of the line. The front of the line makes it into the store. So like this 4 here, it is inside the division bar. So that's an easy way to remember which numbers go where. All right, let's write the rational number as a decimal. The first thing we're going to do is take anything out in front, in this case, the 1, and we're just going to write it as part of our answer. Okay, so our final answer should be 1 point something. Okay, then the next thing that we're going to do is we're going to take the fraction and put it in the division bar. Remember that 5 is at the top. It makes it into the store, so it's going to go under that division bar, then 9 will go outside. Then we're going to put in our decimals and put in some zeros. 9 goes into 5 0 times, but 9 goes into 50 5 times. 9 times 5 is 45. We take the difference, and we get 5 as our remainder. We are going to bring down a 0, and we're going to get 50. Now, notice, we've seen 50 before. This is what we call a repetition. We see the pattern repeating. And so what this tells us is that at this point, it becomes a repeating decimal. Now, let's take it out the next step so that you can see. 9 goes into 50 5 times. 9 times 5 is 45. We take the difference, we get 5 again. So you can see that this is going to go on forever. So this is a repeating decimal. When we write our final answer, because it's just this 5 that's repeated, we're going to write 1.5 with the repeating bar above the 5. So this is our final answer for number 1. All right, now we're going to do number 2. Just like we did with the whole number, we're also going to do the same thing with any signs. So we're going to take the negative sign and write it out front for our answer. We're going to put the 7 under the division bar, the 30 on the outside. We're going to put in some decimal points and some zeros, and then we'll start our division. 30 doesn't divide evenly into 7, but 30 does go into 70. It goes in 2 times. 2 times 30 is 60. We take the difference. We get 10. We bring down another 0, and we have 100. 30 goes into 100 3 times. 3 times 30 is 90. We take the difference, we get 10, we bring down another 0. Now, you should have alarm bells going off in your head right now. We have seen 100 before. So this tells us that our decimal is going to do what? It's going to repeat. Okay? Specifically, it is the 3 that is going to repeat. Because remember, 30 goes into 100 3 times. So since 100 is what's repeating, 3 is what we'll repeat for our decimal. And we could even see if we did 3 times 30 gives us 90, the pattern is going to continue on for forever. So our final answer here is going to be negative 0.23 with the 3 repeating. So remember, put the repeating bar only over the digits that are repeated in your division. Okay, let's take a look at another one. I want you to try this one on your own, so go ahead and pause the video and then start it up again when you're ready to check your answer. To start out, you should have put -2 in front of your final answer. You should have put 3 under the division bar and 11 outside. I put in some decimals and you should have put in some zeros. 11 goes into 32 times. 2 times 11 is 22. I take the difference, I get 8. I bring down a 0. 11 goes into 87 times. 7 times 11 is 77. I take the difference and I get 3. I bring down a 0 and I see 30. Now, we have seen 30 before. There is a pattern of repetition. Okay? And since 11 went into 32 times, then that gave us 8 for 80, 11 went in 7 times. We're going to see, and I'll show you as we continue the division, that both the 2 and the 7 are what is repeating. So let's take a look. 11 goes into 32 times. 2 times 11 is 22. Take the difference. I get 8. Bring down another 0. I get 80. 11 goes into 87 times. 77. So on and so forth. So we can see that the decimal will go on in that pattern, 0.27272727 forever. So we write our final answer as -2.27 with both the 2 and the 7 having the repeating bar over them. And we can go ahead and circle that this is a repeating decimal. Go ahead and try this one on your own. And start up the video whenever you are ready to check your answer. So the correct answer for this one is -1.8. Let's take a look at the evidence that supports my answer. Okay, so you can see my evidence, my work. 9 went under the division bar, 5 went on the outside. 5 does go into 9 one time. 1 times 5 is -5. I take the difference. I get 4. I bring down a 0 so that I have 40. 5 goes into 48 times. 5 times 8 is 40. I take the difference and I get to 0. Remember that when I get to 0, that tells me this is a terminating decimal. So then I brought that 1.8 over with the negative for my final answer. Try number 5 on your own. When you're ready to go look at the answer, go ahead and unpause the video. All right, here is my answer and my evidence. So I put 5 under the division bar, 6 on the outside. 6 goes into 50 times. 6 goes into 58 times. 6 times 8 is 48. I took the difference. I got 2, brought down the 0. 6 goes into 23 times because 3 times 6 is 18. I take the difference and I get 2. I bring down a 0 and I notice that I've seen 20 before. This tells me that I have a repeating pattern here, and specifically it's the 3 that will repeat because 6 goes into 23 times. So for my final answer, I have 1.83 with the 3 repeating. So if I did this in my calculator, I would see 1.83333333333333. Remember that you can always use a calculator to check and verify your answer to make sure that you got it correct. Go ahead and try number 6, then start up the video when you're ready to check your answer. All right, here's my answer and my evidence. So it is negative 0.375. This is a terminating decimal. And when I look at my evidence, I can see that it's a terminating decimal because instead of seeing a repeating pattern, I get to 0. I'm able to finish dividing completely. You can look over my work and my evidence to see that I started out trying to divide 8 into 3 and got 0, but 8 went into 33 times. 3 times 8 is 24. I took the difference and got 6. I brought down a 0. 8 goes into 67 times because 8 times 7 is 56, and I have the subtract 56. I'm taking the difference. I get 4 as the result of that subtraction. I bring down a 0 and get 40. 8 goes into 40 5 times. 5 times 8 is 40. When I take the difference, I end at 0. So it's important to note that you need to keep going until either the decimal repeats or until it terminates at a 0 at the end, like we see with this example. Thanks for watching this video. Remember that you can watch it as many times as you need to make sure that you understand this concept. Feel free to pause, listen to specific sections, but thanks for watching.